All ready for algebraic vectors part 2? All right, we're recording. So I've got I have a vector u, 5, 6. Hey, how do I find the magnitude of u? Just out of curiosity.
5 squared plus 6 squared.
Wrong. 5 squared plus 6 squared is the wrong answer. That's not the magnitude of u.
Square root.
Yeah, there we go. Very good. Pythagorean theorem. So, this is sort of algebraic vectors part 2. And what we're going to do is we're going to look at special unit vectors. Then we're going to go into the third dimension. And then we're going to, once we get done with the, we're just going to go to the third dimension. We're going to look at what vectors and points look like in 3 dimensions. And then we're going to look at direction cosines. Okay, so the special unit vectors. Are you ready for this? Special unit vector. This is called I. It looks like I hat. Okay, there it is. I hat. So just looking at it, knowing it's a unit vector, what do you think its algebraic equivalent would be?
1, 0.
Yes, that's right, 1, 0. So it's just a unit vector that goes along the x-axis. Hey, you'll never guess what this one is called. Just looking at it. What would you call this special unit vector?
J hat.
J hat
Is actually right.
is actually right. And algebraically, expressed algebraically, what would it be?
0, 1.
0, 1. That's right. Okay. I want to express my vector u, 5, 6, as a linear combination of I hat and j hat.
5 I hat. 6 J hat.
5 I hat plus 6 j hat. That's right. So for any vector, it's equal to AB. You could also express it as being A times I hat plus B times j hat. And that's it for the I hat stuff. Are you ready for the hard part?
Sure.
Okay, the answer is sure. We are now going to 3 dimensions. I am about to share the screen because I'm just that generous. Screen share. And I want to share the screen that has the 3rd dimension in it. There we go. Okay, so here we are. We have made it into the 3rd dimension. So, pretend that this is sitting on the page. How would you explain what's happening with the x-axis? The positive x-axis. How would you describe it as it advances towards infinity?
Is there increasing by units of 2?
Yeah, it's increasing by units of 2, but I guess what I'm asking is it like coming out of the screen at you? Is it going out of the top of the screen? Is it going to the right?
It's trapped in the box.
It's trapped in the box. So x actually comes out of the screen towards you, in this case. Y goes out to the right as we progress in the positive direction, and z
Oh,
goes
that's what which direction is it?
Yeah, okay. Okay, so GeoGebra is kind of nice because look, you can rotate this box any way that you want. How's that updating where you are seeing it?
Very jagged.
It's very jagged, like it looks jagged on your screen. Oh, the update's jagged. Okay.
Yeah.
Well, that's exactly what we would expect. Okay, I want to plot the point. So I've got it on here somewhere. I'm going to plot this point. So it has an x coordinate of 3, a y coordinate of 4, and it has a z coordinate of 12. Okay. I'm going to put my cursor right in here. You tell me where I should put my cursor, so advise me which way to go here. Right, left, down, up.
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 And to the right.
And to the right.
Maybe down a tiny bit.
Down a tiny bit.
There.
Right about there?
Yeah.
Okay, let's watch carefully and see if you got it right. That's actually, it looks pretty good. So let's see, how close were you? Ooh.
Oh, I shouldn't have said go back down. Sure.
Yeah, so it was, you're right, you were pretty close. You shouldn't have said go back down. So in general,
I was just thinking the limitations of the box because the axis don't extend out it.
so yes, the box has limitations. So it's 3 in the x direction, 4 in the y direction, and then we are going to go up 12 units from there. So if we go straight up, we have to compensate for that the fact that we've moved a little bit. There we go. So there's 3, 4, 12. Okay, I am going to ask you, see that vector?
Yes.
Okay, I'm going to rotate it a bit. I want you to come up with an expression that tells me the length of that vector. So there it is looking straight down. As you can see, it's in the position 3, 4. Sorry for the big, giant ball at the end of the vector, but that's to make it obvious. So it's in the position 3, 4 here. And if we looked from the side, so here's the z-axis, here's the y-axis. It's in the position 4, 12 here. Okay, and then we can actually look at it in, we can look at it in the other orientation. So looking at it in the y direction. You can see that it's 3 and up 12 here. Oh, last time I said 3, 4. I was totally wrong, wasn't I? Yes, I was. Okay, so I want you to think about it for a minute. I want you to try and come up with an expression for the size of, what did I call that vector anyway? Any ideas? What do I call that vector? I call it u. So this is a new u, not the old u, but the new u. And we said it was 3, 4, and 12. I want you to come up with an expression that will calculate the length of u. And, yeah. Tell me an expression that will calculate the length of u. Oh, like you putting it on your screen, or? Oh, yeah, let's do that. So you think, you have the audacity to think that you can just take the Pythagorean theorem and just put the third coordinate in just like normal and come up with the magnitude. Yeah, you're absolutely right. Yeah. Yes.
Because what I was doing originally was the square root of 3 square plus 4
Yeah.
square.
Yeah, that's right. Yeah. So what you're saying is you actually started out this way, and I can actually remember the day that I did this. So you found out the size of the base of the triangle. You said, oh yeah, that's like 3 squared plus 4 squared.
Yes.
So you found out the length of the one side, and then in order to find this, you had to square that, and add 12, and square root it, and you're like, yeah, perfect. That's exactly right. So it's kind of neat, but it makes perfect sense when you think about it. Really, you're just finding one side of the triangle, 3 squared plus 4 squared, x squared plus y squared, square rooted, squaring it, and adding in the other side. And Bob is your uncle. Okay, really good. Want to see what that looks like?
Sure.
Okay. So, Cheryl, this might take more time than is valuable. So I think the triangle that we're interested in is,
Leave one.
so there are the three sort of edges of the triangle, okay?
You have D and H have the exact same value.
D and H. Oh yeah, okay. But we won't worry about that right now. Okay, there's the triangle that we're looking at, okay? And, oh wow, oh, that's switched me away from 3D graphics. So, as you can see, that's still a right angle triangle, and so the Pythagorean theorem is going to apply. So the tricky part isn't finding this. In this case, it's labeled B3, because that is just the z coordinate. The tricky part, or the not so tricky part, depending on your view, is finding the length of C. C3, rather. And really, that's just another triangle problem where you're trying to find the distance, or the hypotenuse of, in this case, the 3, 4, 5 triangle. Yep. So that's all you're doing. You're just kind of doing the Pythagorean theorem twice. Perfect. Okay. Oh, maybe I shouldn't stop presenting. Maybe I shouldn't stop screen sharing, because the next thing is the direction cosines, and then that's going to be it. How does that 3D thing working for you? Not bad?
Like the way of finding out the.
Yeah, and visualizing it in 3D?
That wasn't that bad.
It's not that bad, actually, yeah. Okay, here we go. Thank you. As you can see, we have the mysterious,
If only it follows your hand.
so, yeah, that would be better, wouldn't it? It would follow the hand. Okay, yeah, you have to decide if it's being disconcerting or not. I think if you move dramatically,
Like it's no longer showing the
yeah,
direction.
so it's like, just comes up with enhanced ugliness every once in a while. Okay, so direction cosines. So it's cosine of an angle between the vector that we're interested in and an axis, and I hope I spelled axis right. Okay, so it might be the x-axis, it might be the y-axis, or it might be the z-axis. Okay, but basically we just find the cosines of those angles. Say, did you magically also calculate the length? It's IS. Thanks, Google. Is that the plural?
I typed in x-axis and that's what it gave me some.
Okay. All right, and n-axis, so yeah, it's singular. Okay. So what do we need to find the cosine? How do we calculate the cosine? Besides the angle and like press your button on your calculator. What is it if we've got a triangle?
And like which sides it would be. Or it could be this one is opposite of the other one. So
Did you say cosine?
adjacent.
Cosine is adjacent over hypotenuse, yeah. Okay. So remember when u was equal to our 3, 4, 12 triangle, did you calculate the actual magnitude of u?
No, but I can use it together.
Oh, because
And so that's 13.
yeah, it's 13. Oh ho! Pythagorean triples that work inside of each other. That is perfect. Okay. So let's figure out what the direction cosine is for the x-axis. So we're going to figure out cos alpha for the x-axis. So this is the angle between the vector, the vector and the x-axis. And what I'm going to do is, because I don't necessarily like
the camera being right here.
the camera showing my beautiful face. Okay, so what? Okay, so that's not actually the polygon that we're interested in. We are interested in the angle between this and the x-axis. So I'm going to get rid of h, and I'm going to see if this is the polygon that I'm interested in. Yes, there it is. Okay. All right. See that triangle? Should I zoom in on it? I'm going to zoom in on it. Darn it. Okay. So if you
This
look
is
at
when
it,
this is when I say that not having that box there would a little bit be more.
yeah, if it didn't cut it off, it would be a little bit handier. Okay. There it is. Do you see that it is a right-angled triangle? Are you satisfied that this is a right-angled triangle?
I don't know let's catch this.
Really? It's a right-angled triangle.
All right.
I can reassure you.
I know chemistry. I know how that works.
Oh, you know how tricky that is. Okay, so it's a right-angle triangle.
No, well you shake your head up and down.
What we want to do is we want to find the angle in here. So, which one of these is the hypotenuse?
B.
Did you say U?
Sure. Well, it said B.
Okay, it said B. So this is the hypotenuse, right?
Yeah.
Okay, and which is the adjacent side?
The x-axis.
The x-axis is the adjacent side. How long is the adjacent side?
3.
3. Yes. Okay, so our direction cosine for the x-axis, we're going to say is cosine alpha. And using our example, what is cosine of alpha?
3 over 13.
It's 3 over 13, yeah. Okay? Or it's the x-coordinate over the absolute value or the length of the vector. Okay.
You're not sharing the screen. Or you're not.
Oh, I'm not sharing the screen.
You're sharing the screen, not showing the.
Not sharing my beautiful face. There we go. Yeah. Cosine alpha. 3, which is the x-coordinate, over 13, which is the length of the vector u. Okay. So, what comes after alpha?
The inverse of those.
Yes, actually, we'll work out these angles and we'll compare them to what they look like. We'll compare it to what they actually look like in GeoGebra when we measure them. So we'll calculate what the angles are. Okay. All right. Okay. So I'm going to share my screen again. You ready? Got it. Okay. So we're no longer interested in that triangle. We are interested in, let me see if I can find it.
No.
That triangle right there.
Where
Okay.
it has an adjacent of 4.
Yes, so it has an adjacent of 4.
So 13.
So cos beta is?
Did you stop sharing?
Yeah, I did.
Mine hasn't updated.
Yours hasn't updated yet?
Okay,
Okay, good. Skills grade is
4/13.
4/13. Yeah. Okay. In
Which
other words,
Y
that's
over
the y coordinate over
100.
length of u. Very good. Okay. Ready for the last one? Can share my screen. Yep, one more time.
Which close is this?
And so this is gamma. So we're going to call this one gamma. And we're going to get rid of that polygon. Is that it there? Yeah, I think that's it.
Did you use the equal?
Yep. Yes, it is. Yep. Okay. So the hypotenuse just remains the same as before, and the adjacent is the z coordinate. So we're seeing a pattern here. No big surprise. Okay. There's the there's the adjacent. There's the hypotenuse.
There we go. Let's see. Let's do this one.
12 over 13. Yep, that's right. Okay. All right. Oh, and that's just z coordinate over the absolute value of over the the length or the magnitude. Okay. Out of curiosity, we should actually work out what these angles are. I'd just be interested to know. And then we'll measure them on GeoGebra. One, 0, 12. And I want to measure my angle. Sure hope we get the same thing.